Hey there, Donald from Thailand. Looks like you got a part here. It's called wheel axle. Kind of want to go through a couple things with you and see if we can get you straightened out. So here's your part. You pretty much have a revolution, goes around, and you got a little thing here, a cut there, and the center hole. You're doing a lot of work over here, going through the part, so I'll try and see if I can get it sorted out and what we can do. So I made a copy here. First thing I know is your sketch. So if we go into it, you always want your center line to be on the origin. It just makes things a whole lot easier. So first thing we're going to do is I'm going to delete this constraint, move that up. You got some degrees of freedom going on here. So show this. So those things are going up and down. So if we move this up, there we go. We get our origin point back on, so if we go to our center point and project the geometry, it comes back up as a little yellow dot, and drag that back down to the origin. So now we have some degrees of freedom. Let's take, you got some redundant lines here, so there's this line and this line. I'm just going to delete this one, make sure that this one's horizontal, and drag that to the origin. Let's go down here. Okay, so if we make the center line a center line, actual center line, if we do dimension to it, it'll put a 304 diameter instead of a dimension like this, where it's 152, it's a half. Same thing with this. We delete that out, put center line, and put these two in line. So now we have a fully constrained sketch. You always want to make sure that that's fully constrained. Now a couple of things is you'll notice that this has a little nub here, and there's a center hole. Well, there's really no reason we can't define all that in one sketch. Some people like to put it in two sketches. I just like to put it all in one because that's how I've always done it. So looks like your radius here is 158. So let's go to your sketch. So your diameter here is 315. So let's go over here. And make this 315. Alright, let's trim off that. And if we wanted to extend that up, it's not going to let us. So if I look at this part, you have it dimensioned. So I wonder why I can't extend it. Well, the point is the point is being dimensioned, not the line. So when you move the point, you can see how it goes up and down. It's not a horizontal dimension, it's a point-to-point dimension. So if we dimension from that line to this line, same measurement, but now this point can go up and down without tilting. So we can then trim it and actually get a good dimension. So a good practice would be from dimensioning a line to a line instead of a point to a point. I'll show you why. So, like this. I don't know what the other one was, but this doesn't matter for this. So again, we're still fully constrained. Let's say we want a line on the middle. It comes like this. And that dimension is whatever you have for your center hole, which looks like it's 0.096 maybe. Let's go back here and see. 0.192. Okay. Alright, we can press X, a hotkey that I set up. I don't know how yours are set up, but now you'll see that I trim those. What you could do is split and then make these construction. Just kind of depends on your preference if you want that line to exist or not. I just like trimming them and then using the coincident to go to there into there. So that links this dot with that line. So that way, if you ever change this to 0.8, it'll stick to it. Same thing with here. If you wanted to have your arc, typically you don't have it going to a tip like that. There's usually at least a flat of some sorts, depending on what it is. It's like, I think back in the day it was 05. And you can make this one tangent, so it'll be a perfect sweep all the way through and define your radius. So if we went back to our wheel and looked at your fillet, it's 125. Trim that, trim that. So that way, when we actually revolve the part, all we're looking at is this solid is going to get revolved around. Now, you also said that you wanted some grooves on this end, so we can add those in as well. So if we come down and over, you could use a pattern, but I don't really like using patterns for this instance. I'll show you why. So, make our dimension 0.015, let's say, and 0.05. And the dimension from the end to the end is 0.08. That, trim that, trim that. Make all these equal, so that way you only have one dimension, so they all control the same thing. And you'll see a couple things jumping around. Dimensions are something you'll have to figure out, but two dimensions needed. Where are they? Okay, so if we have this be the same. So now we're fully constrained. We have our bump here, we have our grooves there, we have our inside cut. So let's finish our sketch and see what happens. It's going to say there's errors because you have all this other stuff, so we'll say accept that, and now you have your part. Now you have all these other stuff, you'll get some, you know. So we don't need this one, so let's delete that. So your sketch is broken. And really, I'm going to delete all these. Okay, and we don't need this work plan anymore. So, now we have our part. And the reason we did it that way is so you have your end, you have your mid plane in the middle, and you have your other plane in the middle, and your axis is along the center line. That's what makes that sketch on that center line there on both planes. So if you ever need it in the future, you know where all your axes are. It is really helpful and kind of important. So now that we have one sketch defining everything, now we need to make our slots. So if we make a sketch on here, we can project the geometry of this edge right there. If you press F7, it'll cut through the entire sketch. That's good to know. You can either use a center hole rectangle or a two-point rectangle, either way. In this case, I guess it doesn't matter, but make our little thing here. Make this line on that line. And the center line of that to the center point of that. So that way, when you change any dimension, it'll change. So let's say our slot is 0.08. Length is 0.3. Finish our sketch. You can extrude it, cut both ways through all. And you get your part. Now, if it was a four-hole slot there, you can use the command here. Use our axis of rotation. You can either select the part or the axis itself. And 4 slots. And then it cuts it both ways. Now, if you're making contacts and connectors, there's different things you can do, but I don't think that's really what we're into yet. So I hope that helps. But yeah, you can either do that after the fact and cut it in. So if we were just in your part here, get a little long-winded, but that's okay. Could create a sketch just on this plane, project our geometry here, draw our sketch, finish our sketch, revolve that as a cut around the axis. So we don't have an axis because we can't use any of these, and we can't use the center point. So we'd have to create an axis like that and then revolve it. So if we did it at the center, we could just use that other axis. But now our center axis is going to have to be there. So we do our cut, say OK. So we got a little deep there, but obviously you can see how it's kind of working. Move that up a little bit. And if you really wanted to, you could pattern this, the direction that way. It's 3 of them, spacing at 0.04. So using your part, you can either just draw another sketch and then do it like that, or you could redefine it, which I'd recommend on the center point. So hope that helps.